Good afternoon, guys. So, we are gonna be talking about a series of RF exploitation attacks and what are the different attack vectors which are focused mostly on physical layer of a communication system. Reason why is because mobile and IoT means that wireless technology is more diverse and incumbent, and it's ever been so. With that comes many more attack surfaces. So we are very excited to talk about the IoT attacks, and my name is Harshit Agrawal. I am security researcher and an undergrad student. Along with me, Himanshu Mehta. He is working for Semantic as of now.
So, can you hear me?
No.
Hello. Yeah. So I'm currently working with Semantic and I'm leading the security intelligence team there in India. And my focus have been always on to learn and explore more into the security field. So I'm also the board member of EC Council LPT program. Like I work along with them, and as well as I'm board member of several other security conferences. So
Before we begin with this session, we need to know how many of you are familiar with SDR, the software defined radio. Okay. And how many of you have looked into some kind of IoT security or IoT hacking before? Okay, it's interesting.
So this session is going to be very, very basic because we got a lot of invitations and suggestions from people that nobody talks about the basic sessions. So, okay, let us start. Yeah. So we are going to begin with a brief historical rundown of the development of the IoT. So our today's agenda will be discussed. So evolving radio technology landscape, then security applications of software defined radio, and what makes the secure RF communications unique. Then we'll be also discussing in brief about the top wireless vulnerabilities, then what are the privacy rules, regulations to RF. So in this case, like you can see the statistic here, it shows the number of connected devices worldwide from 2015 to 2025. So you can see it's like exponential growth. Like if you see compare 2015 to 2020 and 2020 to 2025. So it is going to expand even in coming future. So you can see here like it is almost forecasted to grow to the 31 billion worldwide. Okay, so the overall IoT market is projected to be worth more than $1 billion annually from last year onwards.
And the most interesting part to note about it here is between 2017 to 2018, there's only 3% hike in the IoT devices, but the attack surfaces increased by 600%. So that's really massive. Yeah.
So now a lot of people are learning about that, and they are also applying those techniques to exploit these IoT vulnerabilities. So, and you might have also noticed that the detection of cryptocurrency miners increased 8,500% in Q4 in 2017 year, right? So the attackers nowadays, they are using even some of the ransomware attacks to attack these IoT devices and ask for ransoms. So if you see, the most important thing in this is like we'll be discussing also about the IoT OT landscape. So the combined market of IoT you will see is going to be a 520 billion in 2021, which is massive, and it can be even more than that, what is projected. Yeah. So there are OWASP has released the top 10 vulnerabilities for the IoT, and we have highlighted only 5. So you can have a look in the OWASP top 10 module. So first one is like weak guessable hard-coded passwords. So you know, like most of the devices, even manufacturers, vendors, they don't really care about these, right? So they just give the hard-coded passwords and you don't even have the option to change it. Or maybe you can reset it even after changing. So that is the first problem. Another one is like insecure network services. So you can see there are so many services running on the device itself, and there are some services even vendor does not care like who is communicating with what. Okay, so those are actually exposed on the internet. Like if you use the shodan.io and all, you can see like what are the services running. And the most important thing is like CIA triad, like confidentiality, integrability, availability, and also the authentication. And then third thing is important thing is insecure ecosystem interfaces. So you will be seeing like a lot of API, backend APIs, cloud services, and mobile interfaces in the ecosystem, which is outside the device, but that also allows the compromising of the devices. Yeah. And then fourth is the secure update mechanism. A lot of vendors, they don't even use the hashing and other techniques. Okay, so the lack of ability to securely update the device actually makes them more compromising to these kind of attacks. And then the fifth one, which we have highlighted here, is use of insecure or outdated components. I know you all are already aware, like even for OS softwares, we always ask them to update. So it is same for the IoT devices also. We always want to update these components libraries, whatever we are using in the IoT devices. Then this is a normal IoT threat model that we prepared. Like you can see here, like controlling device. So like how the devices are being controlled, like in our smart homes or tablets. Oh, sorry. Okay. And other things like whatever smart devices you are using. So who is controlling that device? That is the first threat vector, right? Attack vector. The second one, what we figured out was cloud service. So everybody is talking about cloud service nowadays, like whether it is AWS, Azure, Google Cloud, any service, right? So they try to implement that with, integrate that with IoT devices, but they don't know about those injection attacks and S3 bucket leakages. So we have to take care of that also. Then global network, like, it's connected to all the internet related things. And then local network, like in CAN, if you see, like it is using CAN in the some of the devices like cars and other models. And that is also a point of compromise for these devices. Then things like which can be remotely controlled. It can be anything like maybe a refrigerator, a smart home, or anything. Yeah.
So for Internet of Things, it's not only that you need to secure that device, but there are so many different attack vectors. It might be possible that of which cloud services you are using. If that cloud service is not protected, then again your IoT device is possible to crack, as well as the local network through which protocols we are using.
But Harshit, I have one question. Like, can we analyze what is actually inside radio wave spectrum? That will be interesting to know.
Yeah. So when we talk about what basically lies inside the radio wave spectrum, it's the following figure shows the frequency allocation chart, where we can see the different frequencies and their applications on which these devices are working. They need to be concerned from the NTIA and FCC regulations. So they are using that frequencies. We can see FM radio operating on 100 megahertz, the GPS and cell phone somewhat near to 900 megahertz, while the ADSB signal get broadcasted on frequency 1090 megahertz, which can be directly captured from your RTL SDR, and you can track any flights. As well as many cars are now controlled from mobile devices over GSM, while even more can be unlocked and ignition started from wireless key-fobs over RF. All of these are subject to attack with low-cost tools such as HackRF, HackRF and our GNU radios. Using that, we can modify them. Invisible and ignored, our devices are currently screaming out large amount of information about us, our habits, our patterns, as well as what we are doing. So we will show you how to listen in what is commonly being broadcasted, what can be done with this information, and how can we minimize the risk. Here, it's an example. We all might be familiar with the Mr. Robot. It's a scenario from that. So she can be anyone. Let's name her Alice. Carrying no identity card, but still, what she is carrying is yelling out enough information that anyone who cares to listen can find her home, know about her work, see what electronics she owns, and whether or not she got in camera. Let's consider simplest example of Wi-Fi. When not connected to Wi-Fi, our phone yells out probe request asking for network to connect. This probe request contains phone MAC address and recent SSID. Each MAC address is unique and identify manufacturers and are encrypted in Wi-Fi frames through which we can get to know, okay, these are the locations he has been. Like suppose if you have connected your Wi-Fi at Amsterdam airport, so that beacons might be broadcasted and you can track, if someone is on a trip, we can track all of his history where he has been before. As well as the problem with IoT devices is it's embedded, it's unsecured. So most of them are battery powered, limited user interaction, lack of crypto. Based on that, let's understand what is SDR. the software-defined radio. It's a radio communication system where components that have been typically implemented in hardware. Like before, we used to have mixers, filters, amplifier, modulators, all of them as a separate unit. But now they are all easily implemented by means of software. So using software to replace most of hardware, it's a SDR. It uses the software RF IQ samples, like the imaginary samples, through which we can capture the raw data and play with the signals. For modifying and broadcasting any signal, first comes the source, then comes the filter. Source, which is capturing the signal, the antennas. Then comes our filters, how we are going to modify that signal to analog to digital and digital to analog. After that, converter, the sample conversion for our PC rate. After that, demodulator, like we need to demodulate that signal based on AFM, FSK, PSK, what modulation it is using. And after that, the audio sync to modify that signal. So, what are the different hardwares and softwares available in the market? Some of them are HEC-RF1, which is open source. It works from frequency 1 megahertz to 6 gigahertz. We can easily receive and transmit signal from it, as well as the RTL SDR, which works from frequency 1 megahertz to 1.7 gigahertz, but we can only listen to signal from it. On a software side, we have GNU Radio, the GQRX and Audacity, through which we can modify the signals. Now, Himanshu, can you please tell me, this was all about the hardware devices, why we need to look about it, and what are the different things available over there. But I have 3 questions. How should I plan my attack? Like, what does our device do in normal operation? How do they connect? And determining the frequency. How can I plan my attack?
So, Harshit, actually, to do that, we need to do the initial profiling for our device. And these are the 3 questions that every user should ask whenever they start analyzing these devices. Okay, so the first question, like what you asked, like what does our device do in normal operation? So we need to take a look at all the components. There is a receiving station which sets off alarm based on opening doors, for example, motion from a motion sensor and pressing of a doorbell. Okay, so this is like the normal operation. So we need to understand that. Then we need to understand how they communicate, how they connect. Okay, so all of the devices, these devices are connected to each other via wireless medium. They are not connected to any sort of local network like wires and all. So they are all communicating in an unknown frequency. This is important to note because we need to determine that before we start hacking them. Yeah. And the third question which you have asked is like how we can determine the frequency. So this is very important. Like we can do it like very easily by able to replay the functionality when initiating the actions within ourselves, like using HEC-RF. But what else is going on with the radio transmissions? That is, in order to monitor the transmissions in a very simple way, we can use some tools like GQRX.
So as you told about the frequencies, frequency might be anything.
Yes.
How will I get to know that, okay, from a frequency of 1 megahertz to 6 gigahertz, it is the frequency on which my device is working? What are the initial steps I need to take care of?
Yeah. So for that, there are different phases of radio frequency attacks. So we need to first understand that. Like for information gathering, you can see like it is a good starting point. Like if you have some luck, always search for the FCC ID. That you can find it on the website like fccid.io, and there are other websites also. If you can extract that information, you can also find some of the internal images, external images, user manuals, test results for wireless devices. So you don't need to go to any other place, or you don't even need to break your device in order to get that information. Okay, so that is the first thing. Then another important thing is frequency. So frequency, actually, it is the number of occurrences of a repeating event per unit of time. So what we need to note here is, it is a fast Fourier transformation algorithm that computes the discrete DFT, that is discrete Fourier transform of a sequence. So we need to understand that particular algorithm, how actually that works, and how it converts a signal from its original domain, like often time or space, whatever you take into account, to a representation in the frequency domain and vice versa. Then third thing is the modulation. So modulation is like hiding a code inside a carrier wave. So So you will see a sine wave, cos wave. There are different kind of waves, right? So you need to see what are the codes that are hidden inside that wave, and also like representing digital data as variations in the carrier wave. Then there is the fourth one is the transmission. So transmission is nothing but it generates the message from above extracted details. So whatever we have performed from these past, these 3 steps, that we are going to use in the transmission phase. So Harshit, my question to you is like, okay, so we already know about these 4 phases. So can you give one good example where we can use these IoT components in any of the field?
Yeah, so let's take an example of aviation. Why not? Like cars are turning into computers on wheels and airplanes have been flying data centers now. But this increase in power and connectivity has largely happened without designing an inadequate security protocols. IoT can improve multiple aspects of an airport, such as by regulating traffic flow and helping passengers navigate using Wi-Fi beacons, NFC tags and geolocation, streamlining security checkpoints with biometrics like facial recognition and reducing the number of lost bags using electronic luggage tags and sensors and more. So here we can see there are so many different attack vectors being possible when we talk about the aviation. There comes in air traffic control, there comes the infrastructure, the fire alarms and sensors, there comes how we are taking our care of our baggage, and there are so many different attack vectors being possible at the aviation itself. So Himanshu, can you please explain what is the simplest way to get into attack in any IoT device?
Yeah, so we would like to just show you one demo. Maybe that will be a good thing. It's a simple demo. So what is happening here is like Harshit has recorded the signal. Okay, we recorded the lock unlock signal of the car. This is the first experiment that we tried on our car. And what he is going to do is like he is going to perform replay attack. Okay, so you can see he has already captured the signal. Can you see that? No?
Yeah. No, it's not visible over there.
Okay, sorry.
Okay, so
yeah. So no problem. So what we did is like we captured the frequency, and the same frequency we performed using hack RF device. We transmitted the same frequency to lock or unlock the car. Okay, so you can see here the script name like a hack RF transfer, and then this is -R and then the file name to read the file name and then the file on which the frequency will be transmitted. So this is the one thing. And what is the advantage of this replay attack? So first advantage is you don't need to have any knowledge, because when we started using the hack RF device, we actually don't have any idea about the frequency. We just need to capture the frequency on which the car is getting locked and unlocked. And then there is like effective even if the message is encrypted. Sometimes you just need to replicate and even it works, because there might not be proper authentication mechanisms and all those coming into picture for some old cars. Now some smart cars, they do implement these techniques. Then there are also some disadvantages, like we cannot create a valid message from scratch. We need to record it and then we can modify using some tools. That is possible. And another one is like we cannot play with messages. Like many times you'd like to modify a message based on the original one. Sometimes it doesn't allow you to modify because they might be adding some noise or it might be encrypted. We cannot decrypt them. So that time like you will be like just cracking your head like why I'm not able to decrypt it. So those kind of mechanisms if they use, you cannot modify. Then you can tamper with ID and command. Those things are very simple that Harshit is going to tell you in next presentation, next slide. So, and then perform input validation attacks, because there are still some input validation attacks which cannot be performed. This is the one of the disadvantage of this.
So when we talk about the replay attacks, we can surely see that if that frequency is changing, if suppose the data is being not always the same, then replay attack will not work. Yes. So how can we do that? Let's understand first with an analogy of comparison with wired and wireless. When we talk about wired protocols, it's based on voltage, timing and wiring defining ones and zeros. But when we talk about wireless, it's a pattern of energy. Here in a GIF, you can see the different frequency is being transmitted on a spectrum. we are listening on to an 107 megahertz. So data is being transmitted over there and we can see the energy patterns. So our radio spectrum works on a physical layer. Now let's check how can we do the signal hunting. How will I capture and record the signal, analyze, demodulate and decode? So the first step in identifying a radio signal is to determine the operating frequency of the transmitter, on which frequency the frequency is being broadcasted. Other than industrial, scientific or medical bands, the radio spectrum is a tightly managed resource. When we are trying to determine what type of signal we are seeing, we need to first identify the operating frequency. A simple technology is to look at the total width of the signal and then find the midpoint of the signal, which will tell you its bandwidth. In general, this will indicate the operating frequency. With this first piece of information, we can now research frequency assignment tables to determine what type of radio services may be assigned to this specific frequency. Now, there comes the second step of information that is very important. How wide a signal is that shown on the spectrum display. The width or occupied bandwidth of the signal provides us additional information in regards, like suppose we know, for example, that in the case of 2.4 gigahertz ISM band, Bluetooth and Wi-Fi both works. But the frequency bandwidth of Bluetooth is only approximately to 1 megahertz, but while Wi-Fi frequency signal could be up to 40 megahertz wide. In summary, the basic spectrum display allow us to determine the frequency, occupied bandwidth and relative strength for a radio transmitter. So this is how we can determine the frequency. After that, how is it done? So when you find a signal of interest, whether this is signal that should or should not be present in a particular frequency band, you would want to start with the basics. The first step is to look at the frequency bandwidth and a shape of a signal of interest to get an idea about the characteristics and therefore to identify the signal. So for example, many of the 3G and 4G signals have square tops due to the type of filtering they use. Also, this commercial wireless signal use predictable bandwidth. You can make an educated guess on the signal type based on what you see on the screen, like what's its pattern, whether it's ASK, FSK or PSK. Based on that also you can determine. As well as the second step is to perform modulation analysis of the signal. Analyzing the modulation will give further insight into what more of the unique characteristics of that signal. The third step is to capture the signal data and perform additional analysis on that signal. This can be difficult technique because based on some experience, trial and error, we can only do that. When we talk about this, you could look at the RFIQ sample versus time, like how is it the modulation changing, what is its sample rate, or look at the spectrogram to find the OFDM subcarriers if there's any. So, Himanshu, can you please brief what are the different RF attacks which are possible?
So, Harshit, actually, there are many different types of RF attacks, but we did not list all type of attacks because you can always go and refer them. So, first one is like sniffing, which is very common. So, when we begin with sniffing, the massive observation of wireless network traffic, the sniffing is noteworthy because the wireless domain enables truly promiscuous sniffing. This is important to note because you don't require any direct physical access. So, and the method of attack sniffing can be performed by using a radio receiver to passively receive wireless network traffic. And the impact can be anything like data loss, device network discovery, all those things. And then there is another attack which is very common, which is war driving. And it is a type of sniffing only, but that refers to the act of searching for wireless networks or devices. And you can see, like, with the growth of mobile and IoT protocols, war driving now refers to discovering non-802.11 RF networks as well. So there is a different method of attack for this also, like it can be either performed passive or active. And the potential impact can be the discovery of devices and networks identifying exploitable devices. Then there is an evil twin attack, which is known by everyone, like there is an evil twin attack for Wi-Fi and other. So attackers are using even pineapple devices, and the method can be like the attacker must first capture the defining metadata of the infrastructure which he needs to be mimicked, and this may include RF channel information and addressing information like MAC addresses and SSIDs for 802.11. So the potential impact can be the eavesdropping and tampering with network traffic, even data loss and tracking of some of the devices. Then the replay attack, which we already discussed. earlier. And the potential impact of the replay attack can be the change the state of a network or induce the behavior by a device on a network. Then jamming. Jamming is like very frequently used by attackers nowadays. It is perhaps the most well-known attack on wireless systems. Since the radio frequency domain can be thought of a bus that all wireless systems share, loading it up and powerful wideband noise or spurious traffic is an effective way of denying a communication channel. Right? So the method of attack can be like in the simplest form, it can be conducted by transmitting noise within the target of the network's RF channel. That is the same frequency and with sufficient bandwidth and power. So the potential impact can be like denying legitimate network traffic and disrupting the network state, which it is falling in current state. So, Harshit, can you just explain more about the Internet of Radio Vulnerabilities that they should be aware about?
So, first thing is, we often hear about the dangers of dark web. But when we talk about the Internet of Radio, it's not merely dark, but it's invisible. We just have a radio spectrum. We need to determine what is being transmitted and at what frequency. So, the current state of IoT devices is same like the web security back in 20s. So, that is the first thing. Internet of Radio. So the rogue shell towers. We can always create the rogue shell towers, and you can just capture all of your the radio frequencies, and then listen to the what is being transmitted on the two-factor authentication, what is being transmitted on that frequency, as well as rogue Wi-Fi hotspot like the MITM attacks through Wi-Fi Pineapple. Then comes the unapproved IoT emitters. You need to look out what are the different emitters in my frequency range. And in my organization, whether I have allowed that frequency to be used or not. So that is one thing. Then eavesdropping or surveillance devices like the FM and GSM or other radio bugs which are being used over there. Vulnerable wireless devices like low-end keyboards or mouse dongle which can be exploited to RF attacks. These are some of the different possibilities. As well as what if someone turns off thermostat in cold climate for extended period. The water pipes in house can freeze and that can be bursted. As well as the door locks, thermostats like motion detectors, wireless control lights, these are all vulnerable to radio because they are transmitting on the radio spectrum. Bulb can be destroyed by thermal stress. If all bulbs are destroyed, it will disrupt work for some time. So these are some of the possibilities of radio vulnerabilities. Now, the most important thing to know about is the privacy rules and regulation. It is not allowed to transmit and play with signals on, you cannot just listen to frequencies. You need to know about the FCC and NITA regulations of your country. So always check, and as an amateur station must use the minimum transmitter power necessary to carry out the desired communication. You need to check out for the FCC regulation of your country. As well as no station may transmit with a transmitter power exceeding 1.5 kilowatt. Whenever you are doing any kind of research, please keep note of this.
So another important point I would like to add is like in different countries there are different laws. So we need to follow that because most of the governments does not allow us to transmit any signal because there might be other devices deployed on the same frequency level, and we should not be the intruder who should be we are okay. It's okay to capture the signals. It's okay to read the signals because they are allowing it, but it's not okay to perform replay kind of attacks or retransmit the similar signals. Okay. It might cause disruptions to other frequencies that are transmitting. And another important thing is like the steps for compliance for IT organizations. We need to be aware like what data we are collecting and processing, because with GDPR coming into picture, we need to take the consent of the user or company, whether you can really store that particular data and understand the functionality and implement consent. So this is again another important point. Then we need to record everything to meet the requirements of Privacy Act, because as we told, it differs from region to region, country to country. So we need to read them properly, and if required we can hire a lawyer, and then be aware of the policy that is by design and default. And
so walkthrough of what we covered. We talked about the different RF devices, what are the different hardware and software available, how on what frequencies what data is being transmitted, on what frequency which is allocated to which devices, how can we do, what are the different phases. It is advised to analyze the transmitter and reverse engineer them. So we have looked at why the IoT market is changing, how is it changing, and what are the different radio vulnerabilities.
So now let's secure the RF world. Thank you.